As we know, tool steels can be divided into carbon tool steels, alloy tool steels, and tungsten carbide steels, all of which can be used to make tools, cutting tools, dies, and measuring tools. Carbon tool steels have a good cold and hot workability. The highest quenching hardness can reach HRC66 approximately 67. But usually, the tempering hardness is HRC6 approximately 64, characterized by good wear resistance, low price, and have a wide range of uses, taking about half of the consumption of the whole tool steel. High quality carbon tool steels have high toughness and high finish during grinding, so they are suitable for making tools with complex shapes and high precision. Carbon low alloy tool steels are the tool steel by added with CR, W, Mo, VC, MN, Ni, Co, and other alloying elements to carbon working steels to improve the strength, hardness, wear, resistance, and heat resistance to meet the needs of different uses. However, carbon tool steels have poor hardness, and their hardness and wear resistance decrease rapidly when the working temperature exceeds 150 degrees centigrade. This kind of steel has low hardenability when the cross-section size of the tool is larger than 15 millimeters. Only the surface layer can obtain high hardness after water quenching, suitable for making tool parts with small size. Tungsten steel contains at least one metal carbide composition of sintered composite material, also known as tungsten carbide. Its main components are tungsten carbide and cobalt carbide, titanium carbide, tantalum carbide, accounting for 99% of all components and 1% for other metals. These carbide grains are held together by a metal binder and are typically between 0.2 and 10 microns in size. Tungsten steel sintering molding is to press the powder into a billet and then furnace heating and sintering to a certain sintering temperature, maintaining specific time insulation time, and then cooling to get the required performance of the tungsten steel material. Tungsten steel has a series of excellent properties such as high hardness, wear resistance, strength and toughness, good heat resistance, corrosion resistance, especially hardness and wear resistance even basically unchanged at 500 degrees centigrade, and still has a very high hardness at 1000 degrees centigrade. Tungsten carbide is widely used as tool material, such as turning tools, milling cutters, drills, boring tools, etc. Compared with tungsten steel, carbon tool steel is cheap, easy to forge, good machinability, but poor hardenability. Needs to be quenched with water, salt water, or alkaline water. Distortion and cracking tendency, low wear resistance, and thermal strength. After quenching and tempering at low temperature, carbon tool steels have a high hardness at room temperature. But when the temperature is higher than 200 degrees centigrade, the hardness drops sharply. At 500 degrees centigrade, the hardness has been reduced to the annealing state, and the ability to cut metal is completely lost, which limits the use of carbon tool steels to make cutting tools. The tungsten steel makes up for the fatal shortcoming of carbon tool steel because of its good red hardness. The cutting speed of the new cemented carbide is hundreds of times that of carbon steel. Therefore, carbon tool steels can only be used to manufacture some small hand tools or woodworking tools, as well as small cold working dies with low precision, simple shape, small size, and light load, such as small punch, scissors, cold stamping die, cold heading die, and so on.